hope it has nice, well, to make it nice, I'm going to put a 3 here. That'll make it a lot nicer. That should do it. So what can you tell me about this graph? You expect something special out of it? No? Vertical tangent line. There's a vertical tangent line. That's an important feature. I told you when you have a term to the power of 1/3, there would be a vertical tangent line. It looks like this, right? Like this, like x to the 1/3. To get the point where that happens, you need to factor it. So factor out x to the 1/3. Now don't be confused, okay? This one does not tell you that you have a sharp point. It's the original one that we look at. It's the terms. You understand? It's the terms that tell you that there is a vertical tangent line. So what's the factoring for? For two things. To see where the vertical tangent line happens, and to get the x-intercepts. So it happens at x equals 0. Okay? This one. That happens to be an x-intercept, of course. So x-intercepts, x equals 0, and what?
Hey, is this your book?
Oh, I really like this one. How many x-intercepts do we have?
I don't know where her stuff is.
There's 3. Be careful with this kind of thing. You need to do this. You need to take this square and plus minus 3. And then you gotta square root it. And when you square root it, you get the plus or minus. If you don't get that plus or minus, then the graph will be ruined. You just ruin it because instead of passing through 3 points, you got 2 now, and you change the graph. It just destroys you. So about 5.15. Okay. So those are the x-intercepts. Y-intercept, 0. Whenever x is 0, the y is also 0.
I think you can press it.
And obviously, this graph is always continuous. So the domain is all reals. And the range we'll get later. Did we get the range for the previous graph? No. Let me go back really quick. What's the range for this one? All reals. Because this covers all the negatives and that covers all the positives. So all from negative infinity to infinity, all real numbers. Yeah? I just made extrema, right? Yeah?
When we're taking the quiz, are you going to ask us to find the domain and range, or are we doing it for our own benefit?
It's going to be part of the graph. But yeah, I'm going to ask you to state the domain and the range. Does the homework ask you to do that?
No.
I know, but it's an extra thing to do.
Well, how do you visualize the graph? Like, at least where it's starting.
Yeah, I'm definitely going to ask you. You have to state the domain and the range. It does. It does. So if you look at example 1, it says domain. Yes, you will be asked to state the domain and the range.
Did you get radical sine x squared? The sine of you got radical x squared equals 1/3. Because you can just multiply
1/3 and 2/3 is 3/3, isn't it? 1/3 plus 2/3 is 4.
Yeah.
1/3 plus 2/3 is 3/3, which is 1.
But what did you do?
Well, after that factoring, to find the x-intercepts, I set this equal to 0.
Yeah. And then you moved it over.
2/3 is 2 times 1/3, isn't it? You have to do 1 by 1. First you have to cube both sides. So you cube the right and the left, like this.
How many did you miss on the subject?
This would cancel with that. Don't do 3 halves, because if you do 3 halves together, then you miss one of the roots.
Wait, what?
That was the purpose of doing it like that.
What if I multiply it by 1 over 3? You got to negative 30.2.
Multiply by 1.
Why if I multiply to the 1/3 power?
Well, okay, first, you want to solve for x.
So,
Why would you want to multiply it by 1?
if I do it to the 1/3, if I multiply the whole thing by to the 1/3, then 2 over 3 multiplied by 1 over 3 would be 1.
Oh, I see what you're going for.
And then you only get 1 positive root.
Okay,
Okay,
hold on.
negative root.
All right, let me address this fallacy.
4, 5, then you still get perfect.
Okay, we do have an equation right here, okay? You gotta be careful. What we say right here is, I'm gonna cube both sides. I say cube. I don't multiply. I'm cubing the left and I'm cubing the right. Look, this is pretty weird.
How many you finished?
If you
So you got
do this,
By taking everything to the 1.
but if you do that, you're confusing things. You're confusing that with this.
I didn't remember anything.
That's what Brandon is thinking. If you do 1/3, you still gotta use parentheses, Brandon. And now this would be x to the 2 over 9. As opposed to x. You understand what he's thinking, right?
Yeah.
So you think that taking it to the power of 1/3 is like x to the 1/3. That's not the same thing. You see it now, right? Okay, that's what I like. I need you guys to tell me what you're thinking so that we can correct those mistakes. Yes. Functions that have a term to the power of 1/3 will always have a vertical tangent line. Always. Now that you know that there is a vertical, always. Every term that has a power of 1/3 would have a vertical tangent line. To find where that happens, you factor the equation,
There are times when you
and
forget, and then it just
and it would be at x equals 0.
And when you need it, so you factor out the 1/3 out.
Yes.
Because that usually was 1/3.
Right. I was trying to think about, as opposed to something like this, for example, okay? Let me create another one so that you can see. If I had an equation like this, 4/3 minus 2x, there should be 1
Mr. Stanley,
at x equals.
that word.
Maybe, I don't know.
You
Because
gotta
I'm just like extreme on stuff that
No, that's not a good example. I'll think about another example later. Maybe you have one in the book. But the factor is so that you know where that happens. All right, let me take the derivative.
No, for the vertical tangent,
Yes.
is it only a pair of 0? Because you said like if you want to find vertical tangent line, you have to factor it out, and there's like
Yeah. I know there's a vertical tangent line, but to know where that is, I factor that. When I set this equal to 0 and I solve for x, this one would give me 0. So that's the one that has the 1/3. That's where at that value, at x equals 0, there's where the vertical tangent line exists. The other ones are x-intercepts only. They're not vertical tangent lines. They're just x-intercepts. I still got to look back at the original one. There's only one thing that has a 1/3. And there's a vertical tangent line. The factor is to know where that happens. Okay, let me take the derivative now. The derivative should be easy. X to the negative 2/3 minus 1. We should write it without negative exponents, right? It's very important that you do that because otherwise you don't
show
see
you
what's
later.
going on.
Who's going to be conditioned? I'll find a way to condition you high. Condition you. Just whatever.
You see already? Where is that?